Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC. We do everything DIY, and today we're working on a large 4-pipe fan coil unit. Yes, this is the same unit that is leaking. It's actually been 2 days and they're leaving it like this. Look at all that water. I don't know if you guys can see, but it's still dripping right there in the right corner. But as far as today, we're here to replace the BACnet thermostat. Thank you to everyone tuning in to Jumperman Tech. Today we are here to replace the BACnet thermostat. In our original service call for this unit, we were here to replace this thermostat. Then we found that leak. They couldn't shut the water off in the building, and they had it vent and all these things, so they had to turn it back on. And this is the third day that it's been leaking like this. And look at all the bacteria and everything that's growing here. It's still super wet and gross, but it is what it is. We're gonna start by replacing the thermostat, and the idea is to see what's going on. We're gonna replace it and test it. This is not a regular thermostat. This thermostat works off DC voltage and can be controlled by the engineer using his software on his computer. All right, so I just want to take note of a couple things. So let's see. This starter right now is on VFD and it's set to auto. All right, you can definitely see the VFD is doing its thing. It's at 52 hertz, pulling 9.1 amps. I can hear the fan is running. As far as here, we have 3 relays. None of them have a little light on it. Right here, there's these little LED lights, and they indicate if the coil is energized or not. Can't really read these too well, but as far as right now, we got no lights, so there doesn't seem like much is going on here. And then you see all that water there as well. Let's see, I just want to see which valves are open or not. So this is the bypass is closed, that bypass is closed, so they are working this in automatic. As far as this red piece right here, this is actually a large actuator. So they call for heating. This opens the water and sends the water into the coil here. Fan blows across it, they got heat. This is the heating side, this is the cooling side. So as of right now, I don't know if you guys can read it, but it says that one's open, this one is closed. So cooling is closed, heat is open, we got no lights. Let's go ahead and get to the thermostat and see what's going on there. We might have to call the company after we change this thermostat. It's a Delta Controls thermostat, which is now known as their Ainsworth. It's a new company. So let's see if we need to call them, because let's see, where is their hardware? Right here. They installed their hardware in here, and this is actually connected with software on the engineer's computer, and he can control and monitor the system. So this ain't your regular HVAC system. That's their controller. Got some lights flashing in there. Let's go ahead and look at the thermostat and see what's going on. The reason I mentioned why we might have to call them is because, I don't know, they might have to like program it or like just let it link up or recognize, but we'll see. Hopefully not. All right, so here's the thermostat. We can see we got a little flame and a fan, so it's definitely in heating mode. Let's see. All right, so the bottom is the temperature you want it. So it is set to heat, and it is heating. All right. So it seems like it should be doing what it needs to do, and the thermostat is unlocked. The engineer could actually lock this thermostat with his computer so nobody can actually use it. All right, guys, we're gonna turn the power off over here, and let's see what happens. That's off. Let's get everything kind of staying where it should. Hello?
No, sir, it turned off.
Okay, copy that. All right, so we're working on the right unit. I'll be right there in a sec.
Got it.
All right. That's good. Turn that off. Fan is off. All right. Let's have everything off. All right, so here's the thermostat. There's a little locking screw in here, but can't even get a screwdriver in here because of the tile. So let's pull that out. And we have 4 wires here. So these 2 wires, it says power 24 and ground, so it's 24 volts AC coming here. And over here it says net, positive and negative. Over here it ranges of DC voltage. So this is a BACnet thermostat, not your regular thermostat. It should fit in that space. So let's go ahead and turn this off. Well, excuse me, get this off. As far as the new one, there's a little screw on the bottom where honestly you should use it, but we can't really use it in the space that we're in because of the tiling. Not really the best thing. But let's get that off and get this cover off and make sure that this is going to be the correct replacement as well. I ordered this directly from the company. Okay. If you look on this one, we have the same things, 24 and ground, so 24 volts AC will go here, and then positive, negative here. So let's just swap this out. Power's off. Let's get this off. You know what? Start by disconnecting the little wires and then the plate. All right, we'll loosen that up. Now the wires are out. And now we can take this mount off. Man, while I took this off, this piece just directly unclipped off. Wild. Anyways, it is what it is. Let me see if there's any. There's no dip switches on this one, but on the older one, if you look here, there's some dip switches, so there are settings involved here. This one has buttons and all this stuff like that. This is more like modern. I guess that's just what they wanted, so it should just fit. So now that's like that. We can mount this one like this, and the screws do line up. So let's just go ahead and mount the plate first. It's always good to take a picture of the wiring connections for the other one, and we're pretty much just going to match them up as the terminals that's there. So green to negative, white to positive, red to 24, black to GND. Alright, so the terminations are there. We just loosened up the little screw right here, stuck the wire behind and tighten it down. Everything matches. Let's put the face on, turn the power on, and let's test this thing. And there we go, there we have it. I'm gonna go ahead and turn the power on, and Christian is gonna control the unit from down here, and I'm gonna make my way to the unit. We're gonna check the valves, and we're gonna check temperatures. We're also gonna check those relays and mark them accordingly. All right, let's turn the power on. Johnson controls. The fan started with the VFD. Man, I think it's dirty. Whew. Jeez. Whoa, look at that. That's insane. This thing is finally breathing. It's like smacking it. Jeez, man. This place is a mess. Alright, BFD, auto. Let's put it in auto. It says alarm. auto. Let's see. Anything opening or closing? Heating valve is still open. That one's cooling valve is still closed. Turn the power on. Let's call Christian. All right, talk to me. What you got over there? The fan just started.
Yep, showing the fan. It's showing snowflakes, so cooling, and man inside the house.
All right, man's inside the house. It shows cooling. All right, let's drop the temperature.
All right.
Press the little negative button. Let's lower the temperature.
All right.
Okay, I see the cooling valve is open. Heating valve is closed.
When I'm pressing it, it's not doing anything. I'm pressing exactly the negative. Am I doing this wrong?
It does show it's in cooling, but the valve did open for cooling and the heating valve did close, so it's doing something. Let me look at these lights. So this says F, so this must be the fan relay. That light is off, but it's clearly on. We got 52 hertz and 8 amps.
Right.
Hold on. Over here, if I'm reading this right, it's for the heat. It says heat valve light off. The light, when the light is off, it's a call for heat. So the light is on, so it's not calling for heat. And then cooling valve, I think it says light on, call for cooling. So right now it's not calling. So these relays are operating. The lights are on now, indicating we're in cooling mode.
Got it.
Can you switch over to heating?
Let me see.
Try to raise the temperature and
Alright, raise the temperature.
try to raise it.
I'm pressing it, but still the same as the negative. It's not. It doesn't seem like it's doing anything.
No?
Yeah, I'm pressing exactly the positive, the plus. Right.
Maybe slide your finger across that area. That might be some weird
That
LC.
line, right? Okay.
Yeah, that line. Try to see if that does anything.
Okay.
Because it did
No.
switch it to cooling. No?
No.
All right, let me come and take a look at it.
Something. Gotcha.
All right, bye.
Bye.
All right, so he can't get that thermostat to do anything. It might be locked somehow. But let's see. As you can see, this one is now closed. It says red and it's closed. And this one is yellow and it says open. So according to the thermostat, his thing does say that it's in cooling. Also, the relays changed and the valves open and closed accordingly, so it is working. Let's see if hopefully we can control the thermostat, nothing is locked, and we don't got to call tech support on this one. All right, something is definitely really weird over here. The man is in the house, shows we're in cooling, but when we try to click this, it says set. Can't do anything, and it's definitely not 94 degrees in here. I wonder where this thing is reading temperature from. We're definitely gonna have to call them. All right, guys, so I just called tech support, and according to him, those aren't even thermostats. They call them sensors because it's just a communicating system. Hey, look what that says. Michael Jackson was here. What? That's so weird. Anyways, so he was like kind of confused as to why they even have outside contractors like me changing the thermostat, but he doesn't really care. But anyways, he still addressed it. So he said that pretty much it's a different sensor, aka I call it a thermostat, but whatever. So what needs to be done is that he needs to change the program, he needs to address it, and the thermistor inside the sensor is different, so they're gonna have to do that accordingly. So he has to do something on his end on the computer in his office in a remote location for this to actually work. That being said, that was one of 4 thermostats that I need to change. This is going to be the next unit. So there's another thermostat in the building that does have that, so he wants me to get the information on that, so he can see if he can get that program, and from there he can kind of just like copy and paste it into the system that I'm working on. Once we know we got that to work, then he can pre-program the next 3 units, so when I change the next 3 thermostats, it's gonna work. So that's the reason why we have no control and we have such an off reading. It's because they need to program it and address it and whatever, and it's just a whole confusing thing. Sure, this stuff is cool, but it really complicates things for the technicians. And now you got this company's stuff with our company's stuff, and it just gets super complicated. So right now I'm just gonna gather information for the guy, call him back so he can do his thing. But right now I'm gonna go grab a coffee, man. All right, so while I'm waiting for tech support to call me back, I just cut another hole in here, and I realized we can actually get a little bit of access in here, man. Look how this thing is leaking. This is crazy, man. What a mess. And right now I'm seeing water like right here. Wonder if it's coming from there. I don't know, man. Could be another leak in here on this elbow, and this is some big pipes. This might be 3-inch, can't tell. And then it tees off into 1.5 inch, but I got the materials to change above the steel pipe that cracked, so thread that off, but they couldn't shut down the water, and this is the heat for, so we, and this is for the heating side of the unit, and we actually shut down. When we shut down the water, it stopped getting hot, but then the water kept pouring out, so we couldn't get the water to stop, so we couldn't do the job. So only thing we could do was try to slow it down, and this is as best as we could. So they said let it leak, and this is already, they have another event today, so they're gonna let this keep leaking, man. It's freaking ridiculous. But I think there's more problems here. And this is another pipe that might be just sweating from chilled water, but these two are hot. Chilled water, hot water, but it's gonna be one hell of a repair when the time comes. Alright, so I just got off the phone with the tech support guy. He changed the program for this controller here, something to read the thermistors in a different way. He did all that stuff, and now I'm just gonna run a quick test. Alright, that's Christian.
Hello?
Hello?
Hello? Yeah, I'm really here now.
Alright, so what you got over there on that thermostat?
Offsetting and the temperature is at 74.
They're both at the same temperature?
Well, yeah, right now, 74, exactly.
Okay, so the number above, the big number is 74, which is the room temperature, and then the number, the
right.
small number on the bottom, which is the set point, is also at 74?
That's correct.
All right, hold on a second. Hold up. I'm making a video. So you can see right there, heating valve is closed. And cooling valve is closed, as it should be. All right, Christian, let's lower the thermostat.
Got it. Okay, it's lowering.
All right. That should open up the cooling valve. And the valve is opening. If you guys can see in the video, the yellow is showing, and it shows open. All right, cool. Let's let that chill for a second. And we need to check temperature. Actually, just took my drill with a self-tapper, made a hole in the duct because we don't have a canvas or anything. So here's the supply duct. We got 54 degrees. That's good cooling. Nothing is mixing, so that is good. It's so wet over here. All right, so Heating valve is closed. Cooling valve is open. All right, Chris, let's raise the temperature.
Okay.
Raise the temperature higher up. Make it warmer than the room. All right, let's see. I can see that the cooling valve is closing. And the heating valve is opening. That's good. Stay on the phone, Chris. Give me a second. Let's go ahead and check temperatures. Gotta give this thing a minute. But we're gonna need to watch the temperature rise. We did flood the coil with cold water, so you're gonna want to give this a little bit of time. But we definitely want to check temperatures, not just check the valves, because we need to make sure that one of the valves aren't leaking by, so we're not mixing heating and cooling. So let's give this a few minutes and let's see what happens. All right, guys, we're at 92.8 degrees. It's honestly been here for a while. We let this thing run for like 15 minutes. Honestly, I feel like we would have a lot hotter temperatures, considering the water is over 110 degrees. It's like 115 degrees water, at least according to that other thermometer, but it's kind of just been stuck here. So let's see. This is probably the supply, and this is the return. Water's coming in to the coil, then out to the coil. Actuator opens and closes according to demand. Right now it shows that it's closed. This pipe right here is a bypass and it's closed. What we can do is, let's close this valve. There's a valve on this line. Let's close that and see if temperatures go up. If it does, the actuator is squeezing water through. It's just been stuck at this temperature for a while. Oh, there we go, just moved. I'm gonna give it a few more minutes. Let's see where this averages out to, but you know, the human body is 97 degrees or so, so this ain't really heat. All right, let me see if I can reach from here instead of climbing up. There we go. Oh, that's fully open. Gotta go down. Oh man, you can't even fully close this valve. It's so dirty here. But the handle hits the thing. Alright, let me see something. Alright, so I had to climb up here. Man, these valves look terrible. Hold on, Chris. Alright, I'm gonna close this. And let's close this line right here. Let's see if anything changes. Man, this looks so bad. Wow. Let's see if we get better heat. Alright, temps went up slightly, 96.8. Really ain't that much. I'd say this thing is doing its thing. It really didn't go out by much. Might be squeezing by a little bit, or just taking extra time to, you know, heat up the coil. But I'd give this a pass. Let's let this thing run. If anything, we can adjust the fan speed a little bit, and I guess just monitor it, but I'd give this thing a pass. Aside from checking those valves, we do have a damper here, which this is a common space. This should actually be a fresh air damper. Fresh air damper, but I guess fresh air is coming in through here. It's supposed to be direct, man. This ain't working right. So this thing is useless. And it is pretty chilly in here, so it's actually picking up air from this room and not directly from the space. not to mention that, look at that, those filters look packed. Dirty filters. So all that stuff is playing a role. So between the water being hot and picking up air from a cold room, you know, we're gonna get those kind of temperatures. But yeah, I'd give this thing a pass for now. From here, we got a few more units to finish up. We got 3 more units to program. Excuse me, he actually already just programmed it for me. We just got to change the thermostat. So I guess from here we're gonna wrap it up. We're gonna put all the valves back in its original position, and we're gonna leave it as is. But I'm gonna wrap this one up here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. And I'll catch you all next time.